Hello student, today I am going to discuss chemical bonding and molecular structure. Last class I have finished periodic table completely. I finished. Now today I am going to start chemical bonding and molecular structure. What is actually chemical bonding? I am telling you. The attractive force which holds various constituents like atoms, ions, etc. together in different chemical species is called a chemical bond. This is the attractive force. The attractive force which holds various constituents like atoms, ions together to different chemical species is called a chemical bond. Means this is the attractive force. Bond is a attractive force which holds various chemical species. Since the formation of chemical compounds take place as a result of combination of atoms of various elements in different ways, it raises many questions. What are the questions? Why do atoms combine? First question. Why are only certain combinations possible? This is the second question. Third question. Why do some atoms combine while certain others do not? Next question also rises. Fourth question. Why do molecules possess definite shape? Then these are the questions we have to understand. To answer such questions, different theories and concepts have been put forward from time to time. These are, first theory I am talking about, Kossel-Lewis approach. Second theory, valence shell electron pair repulsion, in shortcut VSEPR theory. Third valence bond theory, VBT. And one more theory is there, molecular orbital theory, MO theory. Then these theories were put forward to answer these questions. The evolution of various theories of valence and the interpretation of the nature of chemical bonds have closely been related to the development in the understanding of the structure of atom, the electronic configuration of elements, and the periodic table. To get answer, we have to understand these three things. What are that three things? First, structure of atom. Second, electronic configuration of elements. And third, periodic table. Every system tends to be more stable. And bonding is nature's way. See, important things I am telling you. Bonding is nature's way of lowering the energy of the system to attain stability. Means if in any system, in any molecules, energy is less, then that molecule will be stable. They will attain stability. Now I am going to discuss Kossel-Lewis approach to chemical bond or chemical bonding. Actually all four theories I will tell one by one. Then now I am starting with Kossel-Lewis approach to chemical bonding. What is this approach? Listen. In order to explain the formation of chemical bond in terms of electrons, a number of attempts were made But it was only in 1916 when Kossel and Lewis, two scientists, succeeded in independently in giving satisfactory explanation. They were the first to provide some logical explanation of valence, which was based on the inertness of noble gases. Basis was inertness of noble gases. That was the main consideration. Lewis pictured the atom in terms of a positively charged kernel, 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 positively charged kernel. You can tell the nucleus plus the inner electrons. In atom, nucleus will be there, around the nucleus electron will be there. He considered that things. That time he called as a kernel, Kernel, kernel. Then Lewis pictured the atoms in terms of a positively charged kernel and the outer shell that could accommodate a maximum of 8 electrons. It was main thing was that he just considered that in the outer shell there will be 8 electrons. Outer shell that could accommodate a maximum of 8 electrons, that he considered, that he gave an opinion. He further assumed that these 8 electrons occupy the corner of a cube which surround the kernel. Actually, he assumed that these 8 electrons occupy the corners of a cube. Cube you are knowing. Length, breadth, height all are equal in that cube. Then he assumed that these 8 electrons occupy the corners of a cube which around the kernel. Electrons occupy the corners of a cube which surround the kernel. Now actually later on this concept was proved wrong, but he considered like that, he assumed like that. Thus the single outer shell electron of sodium, in sodium outermost only one electron is there, 11 is there total, atomic number 281. Then this one electron is in outermost electron shell, and you know that only in outermost shell whatever number is electron, that is called valency, and that outermost electrons are responsible for reaction. Then according to Lewis, the single outer shell electron of sodium would occupy one corner of the cube, because they consider cube, while in the case of a noble gas all the 8 corner would be occupied. This is his concept. Later on this was proved, this was not satisfactory and modification came. Then this actually 8 electron concept is till date it is important. It is correct. 8 electrons concept, that is called octet of electrons. Octet, O-C-T-E-T, octet of electron. This is correct till date. But they occupy 8 corners of cube that in that modification took place. This octet of electrons represents a particularly stable electronic arrangement. 8 electron means this will be stable. This octet of electrons represents a particularly stable electronic arrangement. This is correct actually till date. Lewis postulated that atoms achieves the stable octet when they are linked by chemical bonds. If any atoms don't have 8 electrons in outermost, Only in inert gases, 18th group, it is there, not with others. Then according to him, that in any atom, if they don't have 8 electrons, then they want to get 8 electrons. That's why that atom will react to get octet, to take the electron and become octet. And to maintain the octet, that is a stable electronic configuration. In the case of sodium and chlorine, this can happen by transfer of an electron from sodium to chlorine. You know that sodium has 1 electron extra in outermost orbit and chlorine has 7. Chlorine lacks 1 electron, means whole complete halogen group, they lack 1 electrons, hence they want 1 electron. Then all group 1, you can say metals have 1 electron outside, hence these metals can give that 1 electron to halogens. Here in case of sodium and chlorine, 1 electron of sodium will give this electron to the chlorine and it will become 8, means octet will be completed and chlorine will become stable. Chlorine will get 8 electron, and also sodium 281, 1 lost, then now only last orbit 8 is there, and sodium also became stable and chlorine also became stable. Here only I want to tell you, sodium had lost 1 electron and sodium, it became sodium ion Na1+, and chlorine got 1 electron, taken 1 electron from sodium, then Cl minus, 1 minus, because 1 electron it has taken. That's why charge developed on sodium also, and chlorine also, that is called chloride ion. After taking 1 electron, chlorine became chloride ion, chlorine Cl1 minus, and sodium also Na plus. Then A plus and minus both will charge developed, both will attract each other, then they will come very close to each other and sodium chloride molecule formed. These things happens every time. Always they want to get octet, always they want to get 8 electron in the last orbit, both side. Electropositive element also, electronegative also, both, means S block, either S group, or this side you come to the non-metallic side, there also, means those atoms who are lacking, you can say some electrons, to get octet, all will react. They are making them reactive because they want to get a stable electronic configuration, that is 8 electrons in their last orbit. That's why they try to react to get this stability, means 8 electrons. Now this I have told you, but now question arises, how Cl2, H2, F2 they form bond? Chlorine, hydrogen, fluorine, HCl2, H2, F2. Here concept is little different, but here also they get octet, that is sure. In the case of other molecules like Cl2, H2, F2, etc., the bond is formed by the sharing of pair of electrons between the atoms. In the process, each atom attains the stable outer octet electrons. Here it is due to the sharing of electrons, they forms a molecule, because in that way they will get stability eight electrons, both will get stability. They will become 8 electron. Octet will be completed. How? As for example, chlorine, Cl2, Cl. Then you know that Cl has 7 electrons. Each Cl has 7 electrons. Then 1 electron both are lagging behind. Then what they will do, both chlorine atom, one atom both will share. They will come in the middle. Then sharing means always both have right on that 2 electrons. Then 7 electron was there. Then in that, out of 7 electron, 1 electron of each has shared. Then now 6 electrons both have. 6 electron, this has chlorine, other chlorine also 6. And 1 each has shared. Then it became 2. On this 2 electron both have right. Hence 6 plus 2, 8. And for the other chlorine atom also same thing. 6 plus 2, 8. Like that way, both got 8 electrons and became stable. Same things is for, you can say, hydrogen. Hydrogen, now see that 1 electron both have. Both have 1 electron. Then both will share. Then now it became 2. Then now hydrogen capacity of 2 electron only. Hence they are happy. Both shared electron belong to both. Hence now they makes the bond H2. Like that way, fluorine, same things. 9 is there. Then this 7 outermost fluorine, outermost have 7. Atomic number is 9. Then now same thing, 7s are there, just like a chlorine. Fluorine also will make 7 are there in outside. Then 1 both will share. Then 6 already both have, and this 2. Then total 8. Like that way, by sharing, they form or they get stability. They form molecule and they get stability because they got 8 electrons. Octet. That I told you about the how Cl2, H2, F2 form the bond by sharing of electrons between the atoms. In the process, each atom attains a stable outer octet of electrons. Now I am going to discuss a new concept. That is some new things. Lewis symbols. Lewis, I told you the name of scientist. Here, what is their symbol? How will you represent? You can say this atom that is given by Lewis. In the formation of a molecule, only the outer shell electrons take part in the chemical combination, and they are known as valence electron. Already I have discussed. Valence electron means electrons in the outermost orbit. The inner shell electrons are well protected. They will not take part in the reaction. They are well protected and are generally not involved in the combination process, or in reaction they will not take part. G.N. Lewis, an American chemist, introduced simple notation to represent valence electrons in the atom. In atom, outermost electron is there. How will you represent? What will be the symbol? Lewis, that is called Lewis symbol. Lewis symbols. How will you represent? Then here I am telling you how to represent. These notation actually are called Lewis symbols. This notation to represent outermost electron or valence electron. That notation representation or notation of outermost electron are called Lewis symbols. 1 marks question. What is the Lewis symbols? Then this is the representation or notation of you can say valence shell electron in an atom. Then here very easy, where you can tell it is very easy. For example, I am telling you the Lewis symbols for the elements of second period. I am giving example. Lithium, Li, lithium. You know that this in second period, what are the elements? First member of the period. Horizontally I am talking about lithium, second is beryllium, third is boron, fourth is carbon, fifth is nitrogen, sixth is oxygen, and after that 7 is fluorine and 8 is neon. Complete I told you from the lithium to neon in horizontally in period. And now see, I am explaining you representation. That is the symbol, Lewis symbol. Lithium has its atomic number is 3. Then 1s square 2s1 means outermost only 1 electron is there. Then that is represented by 1 dot. 1 dot means lithium you will write Li and 1 dot you put just like 1 point. 1 point anywhere around the lithium, either up, down, left, right, anywhere. 1 point you write. 1 point, that is 1 dot, that is called dot. Dot represents lithium. Like that way, beryllium, Be. In beryllium 2 electrons are there in outermost orbit. Beryllium means 4, 1s square, 2s square. Then only you have to consider outermost. Then 2 electrons are there, means 2 dot. You can write Be beryllium, 1 dot up, 1 dot down. This is the representation of Lewis symbols. Like that for beryllium, outermost orbit 3 electrons are there. Then boron, 5 are there. Beryllium already I told you 2, then 2 dots are there. You can write 1 up, other down. Like that way, boron 5. Then 3 electrons are in outermost. Then 3 dot. 3 dot you can write 1 up, 1 down, 1 left. Just nearby beryllium only. Like that way, carbon. Carbon has 4 electrons in outermost orbit. Then 4 dot. 1 up, 1 down, 1 left, 1 right. 1 dot. Dot means it is representing electrons. Like that way, nitrogen has 5 electrons in outermost orbit. 7 is the atomic number. 1s square 2p5. 1s square and 2p5. 5 electrons are there in outermost, means 5 valency. Then 5 dot you have to write. N you write 2 dot together you write up, 2 dot. And left 1 dot, right 1 dot and down 1 dot. Total 5. 2 up, 1 left, 1 right and 1 down. Point, that is a dot. Then this is notation for or representation or Lewis symbol for nitrogen, outermost electronic configuration. Like that way, oxygen also you can write 6 are there. Then 2 dot, 2 dot up, 2 dot left, 2 dot right, 6. Anywhere total 6 will be there. Down also 2 you can write. In the place of up, down also you can write. Then total 6. Like that way, fluorine 7. Then 7 dot you have to write. Fluorine 7, 2 up, 2 left, 2 right and 1 down. Or 1 up, 2 left, 2 right and 2 down. Anywhere total 7 dots should be there. And like that way, neon octet is completed. Noble gases, stable. Then for that 8 electrons are there. Then everywhere 2 up, 2 down, left 2, right 2, and like that way, this way Lewis symbols. This is called Lewis symbol representation or notation of valence electron. Here one more point I want to tell you, these things. Lewis, what important point told that he has considered, he has told about, they have focused, they have given importance for the octet 8. Then you have seen that from starting from the lithium to neon in a period, one electron is increasing, 1 then become 2, 2 is beryllium, outermost I am talking about, outermost lithium 1 electron, beryllium 2, boron 3, carbon 4, nitrogen 5, oxygen 6, fluorine 7, and this 8. Then after the 8, again a repetition will start, means group 1 will start, group 2 will start, group 3, means outermost electron again it will repeat 1, 2, 3, 4, 5, 6, 7, 8. Again it will, after the 8 again it will repeat. Then he has given importance for that after the 8 again it will, new cell will have 1 electron. It means it can lose that electron because new orbit opened having only 1 electron. Hence very easy to remove that electron. Then that electron and 7th means 17th group you can tell, before inert group, 17th group, and which has 7 electron in the last, and again repetition started. That group, they have only 1 electrode in the outer orbit. Then they can form octet. Already I have discussed, because they will lose and 7 will take. 7 electron of halogens, they want 1 electron, they will take from the first group, like that. Example, sodium and chlorine. So already discussed. Then he has focused for this repetition, that after the octet again 1 will start, and that means outermost orbit 1 electron will be there. It can lose that electron, and 17th they require 1 electron. Then like that way octet will be completed for both, for sodium also and for chlorine also. Not only sodium, chlorine, one example, complete group 1 and group 7 members. Group 17 or halogen groups and alkali groups, both will react, and they will form molecule and they will get stability, means octet. Now I am going to discuss significance of Lewis symbols. Lewis symbols, what is its importance? Now I am telling you, the number of dots around the symbol represent the number of valence electrons. This number of valence electrons helps to calculate the common or group valence of the element. This number of valence electrons helps to calculate the common or group valence of the element. The group valence of the element is generally either equal to the number of dots in Lewis symbols or 8 minus the number of dots or valence electrons. Like that way you can calculate valency. You can calculate like this: valency 8 minus the number of dots or valence electrons, or simply the group valence of the electrons is generally either equal to the number of dots in Lewis symbols. Okay, either directly you can tell outermost how many electrons are there, that is called valency. Valence electron is called valency, or sometimes 8 minus the number of dots or valence electrons. Kossel in relation to the chemical bonding drew attention in the some fact. For actually 4 facts are there. 4 facts he has given attention, drew attention to 4 facts. 3 facts are there, 4th is example actually. Then what are that 3 facts you should understand here. In the periodic table, first fact, in the periodic table, the highly electronegative halogens and the highly electropositive alkali metals are separated by noble gases. That is correct. After the 18 groups, before 18 groups, halogens are there. After the 18th group, S blocks are there, alkali metal. Then they are separated by noble gases. Alkali metals and alkali metals are called electropositive and halogens are called electronegative. Then electropositive and electronegative are separated by noble gases. Second fact what he told, the formation of a negative ion forms a halogen atom. The formation of a negative ion from a halogen. The formation of a negative ion from a halogen atom and a positive ion from an alkali metal atom is associated with the gain or loss of an electron by respective atoms. This is very, very important. How does a molecule form? Already I told, again I am telling you because this is the fact, question is asked. The formation of a negative ion, how does negative ion form? Then already told you, when neutral atom will take electron, then negative ion forms. And when neutral atom loses one electron, or not only one electron, if it will lose one electron, then one positive, means that is called electropositive elements. If it is losing 2, then again 2 positive, this is also electropositive. If 3, then again 3 plus, then all are electropositive. And those who will take this one electron, they will take then 1 minus, means anion. Positive is called cation, negative is called anion. Then as for example, halogen takes 1 electron, then they will get 1 minus, Cl 1 minus, fluorine 1 minus, bromine 1 minus, Br 1 minus, I 1 minus, like that way. These are called anion. Then in this fact, formation of a negative ion and a formation of positive ion discussed. That is the formation of negative ion from a halogen atom and a positive ion from an alkali metal atom is associated with the gain and loss of an electrons by the respective atom. Now I am going to tell third fact. The negative and positive ions thus formed attain a stable noble gas electronic configuration. The negative and positive ions thus formed attain noble gas configuration. Means, see, I am talking about alkali metal, they lost 1 electron. Then 2, 8, 1 was there, electronic configuration. Now it lost. Then now 2, 8 means last, now it became 8. Stable, they become stable, they are happy. Now chlorine, they had 7 electron. It got 1 electron, now it became 8. It became also happy. 8 means stable. Both got stability. This is the, you can say, third point. The negative and positive ions thus formed attain a stable noble gas electronic configuration. Noble gas electronic configuration means 8 electrons they have, except helium. Helium also is coming under the noble gas. Helium, duplet, that is called duplet. They are happy only in 2 electron. That is exception. In their capacity is only of 2 electron, and helium has 2 electron. That is called duplet electron. Duplet electron. Then these 2 electron or 8 electron, that gives stability. 2 is only for helium and 8 is other elements. They want 8 octet. For that purpose they will react. Then this I told you, after losing the or gaining the electron, that atom gets a stability. A stability means octet. Electronic will get electronic configuration of noble gas, also called noble gas electronic configuration. Actually this is written. Those who are not getting full I can say noble gas configuration, suppose sodium 281 is there, then how will you write in shortcut way electronic configuration for sodium? Then 28, this is electronic configuration for neon. Then you write in a big bracket Ne, bracket close it. Under the big bracket, 2 big bracket, in the middle you write neon, means you are talking about the 10 electron. And after that you write, because sodium electronic configuration is 281, means 1s square, 2s square, 2p6, 3s1. Then for this 1s square, 2s square, 2p6, this is the neon configuration, stable, and at the end 3s1 is there. Then electronic configuration of sodium will be neon electronic configuration, means in bracket, under the big bracket you write Ne, means electronic configuration of neon. Outside only 3s1 you write, 3s1. This is the way to write the electronic configuration in shortcut. Okay, that means closest noble gas electronic configuration you have to write, closest electronic configuration of noble gas according to the atomic number. Then this I have told you, the negative and positive ions thus formed attain noble gas electronic configuration. The noble gases, with the exception of helium, which has duplet electrons, all have a particularly stable outer shell configuration of 8. 8 means octet, and it is represented like ns2 np6. N, you know that periodic number, n may be 1, n may be 2, n may be 3. Then n is to small n, ns2 np6, s2 p6 means 8. Then now it will become, only you have to change the value of n. Then s2 p6 is common. That's why noble gas configuration is given ns2 np6. And the fourth fact, that is examples actually. Example. Then fourth point is just like example. The negative and positive ions formed are stabilized by electrostatic attraction. Now this I already told you in the beginning only, that this charge, negative charge and positive charge, opposite charge are there, then they will attract to each other. That's why the negative and positive ions are stabilized by electrostatic attraction. Attraction due to charge. Attraction due to charge is called electrostatic. The word electro means it came from the word electron. Then electrostatic attraction. Then this attraction is the force. Then electrostatic attraction, that is a bond, also called bond, B-O-N-D, bond. Electrostatic attraction. Attraction means bond only, B-O-N-D. Then here it is electrostatic attraction. Example, already I have given you NaCl example. Na, first it will convert to, after losing the electron, one electron, it will become Na sodium ion, Na plus one electron. Electron has negatively charged, already you know. Sodium, first it will convert to sodium ion, Na plus one electron. Correct? Lost the electron. And this chlorine, that one electron, sodium has lost one electron. Then chlorine atom has taken that electron, Cl plus E. This E minus you can tell means electron, Cl plus E. Chlorine has taken that electron and now it formed chloride ion, Cl minus 1. Correct? Chloride ion. Then now third step, always you can put one arrow sign. Na is converting into Na plus 1 electron. Then in the middle you write one arrow sign. Means Na is converting to Na1 plus. Then in the between the two you write one arrow sign. Arrow will be towards Na plus, because Na is converting to Na plus 1 electron. Like that way, chlorine is taking 1 electron, Cl plus 1 electron, then it will convert to chloride ion, Cl1 minus. Then between the two, Cl plus 1 electron, it is giving chloride ion, then put one arrow sign towards chloride ion. Then Cl plus E, arrow sign, and Cl minus 1. Like that we can write. Then now Na plus is formed, Cl minus is formed. Then in third step, Na plus Cl minus, it will give you product, as a product, NaCl. NaCl means in the middle arrow sign you write Na plus Cl minus, after that one arrow sign, NaCl. Or NaCl you can write also Na plus Cl minus, together, close. Near the Na plus you write immediately Cl minus, means sodium ion and chloride ion. Then in two way you can write NaCl also is a good, you can write, or sometimes Na plus Cl minus together you can write. Like that way, calcium also same way it will form. Calcium will lose 2 electron and it will form Ca2 plus 2 electron. And this 2 electron will be taken by this 2 electron who will take, suppose you are talking about the formation of calcium fluoride. Then this 2 electron will be taken by fluorine, 2 fluorine atom, F plus E, again F plus E. Then they will form 2 fluoride ion, it will form 2 fluoride ion, F minus, F minus. Then 2 minus and 2 plus. Calcium has 2 plus. Then Ca2 plus and fluorine, 2 fluorine each, 1 minus. Then it will form CaF2, means product will be calcium fluoride. Or I told you, you can write Ca2 plus F2 minus, or F under F you can write in bracket, down you can write 2 also, CaF2, correct. Then Ca2 plus 2F minus, calcium ion and fluoride ion, calcium 1 ion, Ca2 plus, and 2 fluoride ion, Ca2 plus 2F minus. This is the called, you can call reactant, and product what you will get, CaF2 calcium fluoride. You can put reactant and product always in the middle, you write one either equal sign or you can write arrow sign. Then bond is formed. The bond formed as a result of electrostatic attraction between the positive and negative ions was termed as the electrovalent bond, according to Lewis. According to Lewis, the bond formed as a result of the electrostatic attraction between the positive and negative ions was termed as the electrovalent bond. The electrovalence is thus equal to the number of unit charge on the ions. What is the electrovalence? The electrovalence is thus equal to the number of unit charge or charge on the ions. Thus calcium is assigned a positive electrovalence of ions 2. Thus calcium is assigned a positive electrovalence of 2, while chlorine is a negative electrovalence of 1. Correct? Kossel postulation provide the basis for the modern concept regarding ions formation. Main thing is that Kossel main things is that concept of ions. Kossel postulation provide the basis for the modern concept regarding ion formation by electron transfer and the formation of ionic crystalline compounds. His views have proved to be a great value in the understanding and systematization of ionic compounds. At the same time, I told you always some modification will be required. Then Lewis understood at the same time. He did recognize the fact that a large number of compounds did not fit into this concept, and he agreed that it is okay, it is importance, concept has importance, but it will not fit for all you can say molecules. He did recognize the fact that a large number of compounds did not fit into this concept. Now I will discuss this octet rule. Octet rule. What is the octet rule? Already I told you. Again, just I will brief it. Kossel and Lewis, both scientists, Kossel and Lewis, in 1916 developed an important theory of chemical combination between atoms known as electronic theory of chemical bonding. Okay, both scientists Kossel and Lewis in 1916 developed an important theory of chemical combination between atoms known as electronic theory of chemical bonding. Question is asked, what is the electronic theory of chemical bonding? Who have given this theory? In which year? That's why I am telling with year only. Now you are knowing. According to this theory, atoms can combine either by transfer of valence electrons from one atom to another by gain or loss, or gaining or losing, or by sharing of valence electrons in order to have an octet. In their valence shell. This is known as octet rule. Today, now I am stopping only here. Next time again I will continue. Thank you.